Hello, everybody. Dear ladies and gentlemen, welcome to our second webinar regarding the scrubber system. I'm Anwar, part of marketing team. I'm working as product manager for the agri company. In this webinar, we will inform you about how scrubbers work, why your facilities will need them, different types of scrubbers, and also we are going to try to answer your questions. As most of you know, scrubbers are used to clean harmful gases and to eliminate odor problems in industrial facilities. At Agar, we are able to design and manufacture these products, and we are seriously investing for the research and development activities. And Hasan Sarıoğlu is working for R&D department of our company. And now he will present you the details of the scrubbers with this presentation. Welcome, Hasan, and yeah.
Thanks, Enver. Hello again, and welcome on our second webinar. I have a presentation, and I will start it. Let's share my screen. From here, let's start from the beginning. I will make some setting. We will talk about the emission control device. We will talk about the scrubbers, but it's called emission control device as like wet scrubber, wet, dry, and bioscrubbers. What we will talk on this webinar, we will talk about the standards, the general standards about the emission control units. What is these emission sources and which sectors occur these emissions, and also how will we clean this emission with the scrubbers. In the standard side, also you can see the countries, the classes, and in totally 194 countries has a standards or directives to obey the greenhouse gases or the other emission controls. In the directives and the standard sides, European nations has some directives, integrated pollution prevent and controls directive, ambient air quality and cleaner air for Europe directive, and the limitation of VOCs, volatile organic compounds, limitation directives. And also around the world, some agencies, they are producing, they are making these directives and controlling. One of these is European Environment Agency, and also the countries has some companies as like National Environment Agency from United Kingdom and UBA from the German Environment Agency. And also I add Paris Agreement from 2015 because after this agreement, the emission control is highlighted all around the world. What is the pollutant and what is the sources? The EPA, European Environment Protecting Agency, has defined some pollutants as and now 178 pollutants are listed from the EPA. Some of them are in examples as like benzene, perchloroethane, methylene chloride. Those kind of things are the pollutants. The pollutants means, according to EPA, EPA, hazardous air pollutants and the air toxic gases are pollutants. And also another class of the emissions, greenhouse gases. These are like methane, nitrous oxide, hydrofluorocarbons, perfluorocarbonates, and the most important one is the CO2, carbon dioxide. All of the emissions gases refer to the measured by the reference gas carbon dioxide, and carbon dioxide is measured in million metric tons. VOCs, volatile organic compounds. VOCs are really important for the indoor and the outdoor air quality while on your working on your factories or on your working sites. These are causing the headaches, those kind of health issues. The common VOCs are ethanol, formaldehyde, benzene, toluene, and xylene. Also, I will give some examples about the sectors. The plastic production, EPA described the waste reduction model. It's called WORM. To estimate life cycle greenhouse gases emission factor, the values of some plastics. These are LDPE, HDPE, polystyrenes, polyamides, those kind of things. And 288 million tons of plastic is produced in all around the world. And while producing these products, we are emitting the carbon dioxide. And also you can see the percentage of the distribution of the carbon dioxide equivalent. LDP, HDP, those are really common plastic products. So you can see while producing 1 ton LDP, you have emission 1.28 metric carbon dioxide equivalent. And another sector, textile, because I choose some sectors like plastic and textile, because textiles industry knows water-intensive sectors, but also on the textile industry, another issue is the energy consumption, emission to air and solid waste, and odors. In the textile industry, also you can see the limit values. I have a mouse here. You can see on the red line the limit value, and the blue one is the emission value. From the carbon monoxide, also in the air, it turns to carbon monoxide turns to carbon dioxide. The emission value is 40. The limit value is 40, and the emission value is 285. And the other highest one is the total volatile organic compounds. Also, it has odors, the bad smells. The limit value is 2.2, and the emission value from the textile companies, textile factories, 340.
Let me interrupt you for a second. There's a question about that. You were talking about the values, emission values, and some gas values, etc. And I wonder, could you give information about the necessity of the measurement and the importance of its accuracy? I mean, you know,
the measurement
values, we measure them first, right?
The government or agencies are define these values according to global warming and the air quality performance. So these measurements are really important for the world. And after making the measurements, you know what's your point, and you know what will be according to these directives. And according to your firstly, you should check the directive for your sectors, and then you'll know what is the limit value. Also, I will explain from the next slide. Maybe it will be better. I will continue. Another one is the petrochemical industry. Also, the petrochemical industry emissions are carbon dioxide, SOx, NOx, and the VOCs, and some particles. And from the chemical industry, while producing those chemicals, they are releasing hydrogen sulfide, ammonia, benzene, toluene, because these chemicals are really used on the chemical industry. Also, I would like to highlight this one. The chemical and petrochemical industry generates 18% of direct carbon dioxide emissions. In this emissions, the electricity production is excluding, and this is really high percentage emission. While the petrochemical products, what we are producing from the petrochemical things, the olefins, aromatics, and synthesis gases are producing from the petrochemical factories, the companies. And then while producing these products, the greenhouse gases are released from these factories. And I think the last one, iron and steel production. Also, everybody knows that from the Industrial Revolution, the iron and steel is a part of our life. So while producing to iron and steel, NOx, sulfur oxides, carbon monoxide, hydrogen sulfides, those kind of things, those kind of emissions are released from the chimneys, and those are chemicals turns to acids and make an acid rain.
Hassan, let me interrupt you once. There's another question. We are talking about gases and some harmful gases, but in some cases there might be some solid particles in the whole material. I mean, how can solutions be found against the presence of solid particles in the pollutants? I mean, should we change the design of the scrubber, or is there any other method to absorb that solid particles?
The solid parts, it depends to how big these solid parts is, like PM 2.5 or PM 10. From the wet scrubber, we can keep PM 2.5 dust, but if the dusts are big as like PM 10 or bigger than 10 microns, we should add some additional filters, and then the gas should come to after this filter, because the size are bigger, or also it depends to which kind of dust, as like the iron dust or the other thing. It can be a corrosion from the on the scrubber, or it changed to reaction from the scrubber. From the dust side, the solid part side, it depends to how big and what kind of solid parts. Maybe it will be answered.
Thank you. Please go on.
BAT for emission, also EPA also follow this rule, the best available technology for the emission control units. While controlling the emission, while reducing the emission, some changes are listed on here. The waste gas recirculation can be applied, wet scrubbing, regenerative scrubbing, waste gas denitrification, and this is activated carbon process, vapor recovery unit, sulfur recovery unit, or tail gas treatment unit. Also, I guess I wrote some examples as like sulfur recovery unit can use hydrogen sulfate or sulfur dioxide monoxides, and activated carbon process can use VOCs or SOX or NOx group of chemicals.
Again, 1 second. When you mention about VOCs, there's a question about VOCs, about the printing industry. VOC from inks, and solvents are very high for the printing industry. And adding wet scrubber would be a solution, proper solution for these VOCs in the space, because inks and solvents are used very often in this industry, as you know. And another question is, adding that wet scrubbers might be create any problem with existing air conditioning system,
The wet scrubber not affected from the air conditioning unit, but if from the scrubber side, the important issue also I will talk about the later slides. What's the temperature and what's the waste gas inlet temperature to scrubber? To scrubber can use the wet scrubber can use most of the emissions, but some parameters are needed. Sometimes can use activated carbon for as like VOCs. Also, you can see from here the activated carbon process use also VOCs, and also you can use the VRU, vapor recovery unit. It depends to concentration of the VOCs. It depends to type of VOC. It depends to if the solvents are not soluble in the water, or it's not get a reaction with the solution. Also, you should change the method as like activated carbon to vapor recovery unit or wet scrubber. It depends lots of parameters, but we cannot say if our emission is VOC, we need activated carbon. It depends to flow rate, the gas concentration, gas type, reaction type, efficiency, and which sectors. As like you ask about the printing sector, printing company, printing industry. Maybe the same printing company, same pollutants occur from the chemical company, but the values are changed and the systems are changed. The customer demands are changed. So if you use in the chemical company use wet scrubber, but maybe the printing company, you should change the system as kind of absorber, activated carbon, or vapor recovery unit. It depends. It changes from your requirement, and it depends to pollutant flow rates and concentration.
Okay, thank you. Please go on with the presentation.
These are the pollutants and which technology are the best for now. Also, I will explain what is a scrubber, and maybe according to your questions, I will explain what is the design and what is the performance parameter, which sectors are using which kind of scrubbers. I will give some samples again, and what is the advantage and disadvantages, as like the dust can use which kind of scrubber, and also lastly I will give some experimental studies. The types of scrubber. Mainly, we have three types of scrubber, as like dry scrubber, also it called absorber or adsorber. In this one, we have a cartridge system. It's a chemical inside of the cartridge. It's a dry one. So while passing through, the gas come from the the gas come from the lower side and pass through to the chemical cartridge, and the clean is going to clean, and clean gas goes from the upper side. When we will use dry scrubbers, if the pollution concentration is low and flow rates are low, it depends to company. As like the low pollution concentration, low flow rates means less than 5,000 cubic meter per hour, and low concentrations are change from the which chemicals. As like if we talk about the carbon dioxide, 100 ppm is 100 ppm concentration is low for absorbers. And how you use this one? You set the absorbers, and time by time you should change the chemical filters. And in the chemical filters, while the airflow pass through to filters, it has a chemical reaction, and keep the chemical on the cartridge, and the clean air goes out from the upside. And the second type of wet packed scrubber, wet scrubber, spraying unit, spraying scrubber, those are wet scrubber. And in the picture you are seeing the packet scrubber. Basically, the wet scrubber basically in terms of liquid gas and liquid gas phases. Also, liquid gas phases means also we can add the solid parts. In the wet scrubber, divide three main units: the venturi type, spray type, and cyclonic type. And the third one is bioscrubbers. In these systems, we
Hasan,
are using.
let me interrupt you again. After starting, before starting the bioscrubber part, there is a question from one of participants. He says scrubbers can also be used for heat recovery from hot gases by flue gas condensation. There are several methods to remove toxic or corrosive components. Do you have any specific solutions with scrubber systems to neutralize it from exhaust gas?
Okay. Actually, scrubbers cannot use as a heat recovery unit. You can make before the scrubber, because you have to reduce the temperature of the waste gas before the scrubber. Some of our clients use heat exchanger before the scrubber and reduce the gas temperature. And while reducing this temperature, also they are using this heat from the from their air conditioner, or from conditioning the other liquids, as like if you are using oil, they are using this heat from the heating the oil. But the scrubber cannot use as a heat recovery, because you have a chemical reaction, you have a solvent from the here, solutions from the downside, and you have to reduce this temperature because of the chemical reaction. But most of the companies use heat exchanger before the scrubber, and then get heat from the exhaust gas.
Okay, thank you. Please go on with Bioscrubbers.
Okay. From the Bioscrubbers, this is a different technology, as like different technology as like the wet scrubber and the dry scrubber, because in the Bioscrubber we are using the bacteria. We have bio balls in the scrubber, in the packed area, and we immobilize the bacteria from these balls, and the reaction occur in that area. And generally, those scrubbers those scrubbers used for hydrogen sulfide, as like the biogas companies or wastewater treatment companies. Those companies are use bioscrubbers. Also, bioscrubber used for the odor control, because those according to the bacteria selection, you can use the bioscrubber for higher VOC concentration. Also, I would like to watch one video for this one.
Before the video, there's another question about bioscrubbers. Maybe you can answer that from after the video too. But question is that can bioscrubber be used as a deodorizer in wastewater treatment plants?
Not like a deodorizer, because it means the deodorizer means give the good smells. If they called good smells, bioscrubbers just keep
eliminate the bad ones.
Eliminate the bad ones. If you smell bad air, when you get that bad smell, that odor, the smell with like neuter, not like a good one.
Eventually, it's a kind of odor control, right?
So odor control. Odor. Yes, it's an odor control, not like a deodorization or give good smell.
Understood.
Yeah, I would like to watch the video how it's worked to bioscrubber. Also, I will continue. In the bioscrubber, we have two tanks. One of them is the feeding tanks for the bacteria, and this one, because those gases make an acid rain. We have a solution for bacteria feeding in these cans, and we are pumping to bioreactor. And this is the main tank and main chemical solution. On the right side, we have a pH balancing, because the H2S is a acidic compound, so it should be a reduced pH. And bioscrubber can use those one, SOX, H2S, NOx. On the these are the bioball types. It changes according to emission gases. And demisters keep the solvent inside, and the ducts make the pressure differences and keep the airflow laminarly. This has to be on this unit, the IoT, the automation control. You can control from your mobile phone, the tablets, or your SCADA system, SCADA room. Let's turn my slides. Also, as you watch on the video, Bioscrubber make 4 main units. One, the feeding area. The second one is the bioreactor. This called as a bioreactor because the biological reaction made on here. And the third one is the bioballs and pH balancing unit. And bioscrubbers can use the H2S. This comes from the wastewater treatment side and the biogas biogas production companies. And also H2S has a really bad smell. So I called odor control unit to bioscrubber. And the multi-organic compounds, alkalines, SOx, NOx, and those kind of things, you can use bioscrubbers. And also you can see from the bottom side, these are the bioballs. We are immobilizing the bacteria from these balls. Generally, these are made from the polyethylene. The performance parameters are the gas compositions. These parameters, this is not parameters. This is affected the performance. The emission gas composition, which kind of gases inside to airflow, and what is the humidity, which type of bacteria are you using in the bioballs, and type of bioballs. Those are affected to performance of bioscrubbers. Those are some example pollutant gases: the ethylaldehydes, disulfides, chlorines, hydrogen sulfides, mercaptans. Those kind of things are has a bad smells and harmful for the health. And I come from the 32 wet pack scrubber. Wet pack scrubber, we have a solution again from the downside. It's a chemical solution, and we are spraying these. We are pumping this solution to spray nozzles from here, and we have a rushing ring, the pull ring on here, and the pull ring or the rushing rings are increase the surface area between the gas and liquids, and it's create a time for chemical reaction. And the clean gas, the waste gas come from the L point, and after pass through the packet back, and clean gas go out from the B point.
Let me ask you another question about that. You said clean gas is out from that point. I mean, how is it ensured that the absorbed pollutants, we are absorbing that dirty gas pollutant, and we obtain eventually something, a material. How can we discharge from the system in a safe and environmental friendly way?
From the liquid, from the as like the sludge, how we will discharge, right?
Right.
This is how some directives and the rules, the government rules. It depends on the country, but we are turning to the waste gas, the harmful gas, to another things. Like if it's sulfur dioxide, we are turning these as a salt, and it's not harmful to you can directly drain the sewage. But if it is if it cannot turn to less harmful thing, you have to dispose these sludge to some companies.
Yeah, there are some regulations about to, and there are maybe some applications. Maybe the company should.
Yes, disposal companies. Disposal companies can dispose these things, or maybe you can vaporize to water from that one, and reuse this water again.
Understood. Okay, thank you.
Okay. This is the wet packed scrubber, and the design parameters are almost same for the most of the scrubber. The three type of scrubber: the pressure drop, the flow rate, gas composition, gas temperature, gas concentration, and the solution flow rate. And for the three types of scrubber, the dry, wet, and the bioscrubber, also we are adjusting the pH. While designing the scrubber, you have to calculate the pressure drop correctly, because this the air flow should pass through the inside of the scrubber laminarly. If you cannot make this calculation correctly, you have it's changed your fan selection, it's changed your packing height, it's changed the packing material, and this is also affect to parameter the efficiency of the scrubber. The second one is the gas flow rate. According to gas flow rate, the scrubber dimensions are changed. The dimensions and the height are changed. The tower height, tower diameter, and the flow should be uniform, pass through the uniform at the scrubber, and calculated velocity, not high, not low. The gas composition, also, as you know, you are not one gas composition from the chimney. If you burn something, the SOx, NOx, carbon monoxide, carbon dioxide, lots of things occur on this burning. Or it's a reactor not release just one type of gas. We have to define the gas composition correctly. Otherwise, if you select one type of gas, in the scrubber, those kind of cloggage can be occur, and if the clogging occur on the scrubber, cannot work it. And the gas temperature, the polluted gas temperature. Also, you asked the scrubber can use heat recovery. You have to reduce means it's around the maximum the wet scrubber, the maximum working temperature around 80 Celsius degree, and the bioscrubbers can work around 30, 20, 28, 30 Celsius degree. You have to reduce the gas temperature because of the vaporization, because of the bacterial life. So also it's the high gas temperature increase the liquid loss. So you solvent the pH changing. While designing to scrubber, we are following the gas temperature. What should be the gas temperature? The concentration, according to pollutant, the waste gas concentration, is the unit is ppm. It's changed your pump selection, pump power, and the solvents usage time. Depending to pollutant rate, we are preparing a chemical solution from the scrubber and select a pump for pumping the solution from the nozzles. Also, it depends to flow. It depends to solution flow rate. If it's not selecting correctly, the operating cost and the efficiency are really changed. Those are the design parameters, and how we will measure the performance, the airflow, the packing material choosing, packing material height, reaction, what kind of reaction and what is the temperature, the wetting area, nozzle choosing. Those are the affected the performance of the scrubber and absorbers. The airflow should be a laminar, the uniform at the scrubber, the minimum liquid gas ratio meet the requirement of the cleaning percentage. If the airflow is not calculated correctly, pollutant gas leaves the scrubber before completely cleaned. The packing material choosing, the packing materials should choose correctly. If the acidic gas comes to scrubber, you cannot change a steel type of packing material. It will be corrosion and deformed. So this is another important issue affect the performance of the scrubber. These are the type of packet material like bell, rushing rings, pall rings, and the other shape of rings. Those are directly changed to scrubber performance, because it's changed to wetting area, and the packing also. I talked about this one before. It's increased the reaction time and increase the surface area between the gas and liquids. The packing material height, we are using a packing material for increased reaction time, but also this packing material make a pressure drop, occur a pressure drop. So the packing material height should be calculated correctly. And the reaction temperature and stoichiometer. Reaction temperature, because the reactions not occur all the temperatures. And the stoichiometer will be defined correctly from the chemical engineers. Because not when you comes through the oxygen with the sulfur, not always occur sulfur dioxides. maybe sulfates, these kind of things. This stoichiometry will be calculated by the experts or chemical engineers. Automation are, from my side, the automation is affected to performance because I talk about the pH, the reaction time, the flow rate of the solution. These values strictly controlled from someone or from the computer. The automation will control all these parameters, and according to written scenario, they can make adjustment and correction from the system. So the automation is the I think the most important part of the scrubber. What is our differences from the others? The scrubber can keep particle and polluted gases. The particle means PM 2.5 types of gases. The solid parts. Dimensions may be smaller due to the operating at the lower gas temperature. If the gas temperature is reduced, also dimensions of the scrubber will be reduced. So some of our clients use a heat exchanger before the scrubber, so it will reduce the dimension of the scrubber. They are win-win. They are getting the heat from making the heat recovery, and also you need a smaller unit. Also, scrubber tower can use part of chimney heat, and the captured particles not discharged from the chimney as a dust from to air. It's a water-based unit. Those are water-based emission control units, so it doesn't need big maintenance work. High pressure drop can optimize by the calculation, and from the chemical side, with high corrosive risk gases can clean 99%. Which sectors we are working commonly? Petrochemical, fertilizer, chemical, iron and steel, foods, mine, textile, glass, and medicals are some sectors which are served. Thank you for your listening, and thank you for your time. Enver, if you have any question from the participants.
Thank you for the presentation, Hasan. And there is another question, actually one or two questions more. One of them from one of our attendees. He or she says, which scrubber is best in biogas industry, where H2S is 6,000 ppm?
The biogas scrubber.
Biogas scrubber, right?
Biogas scrubber. Also, the difference between the biogas and the wet scrubber can use H2S, the hydrogen sulfide cleaning, but if the concentration is like for the hydrogen sulfide 500 ppm, the dimensions of the wet scrubber is dramatically increased. So they should use the Bioscrubber because you said 6,000 ppm. It's really high. Maybe
Yes.
it can separate it.
And also, as I understood, that biogas scrubber is kind of brand new technology, and it will get more and more popular in the following months or years.
Yeah, it depends to sectors, as like the geothermal energy, the electricity production companies, they have a high hydrogen sulfide emissions or biogas production companies. While making to fertilization, it's release hydrogen sulfide with the methane. So you have to clean this one to good biogas. And this high concentration, you have to use, you don't have another choice. If you don't make a desulfurization, those kind of things, you have to use biogas scrubber. But the biogas scrubber also it's a biological reactor. It works a biological reactor, and because you are feeding the bacteria, if the temperature is really high or the pH are changed dramatically time by time, if you cannot control, maybe you have to use wet scrubber. Turn your decision wet scrubber. It depends to budget and the customer requirement.
Yes, another attendee is asking that about the fish market application, and he mentions some chemicals. If I'm not mistaken, putrescine and triethylaminobutan. He mentions about large amount of these gases, and he is asking for a solution for these gases.
Yeah, you are talking to engineer and you said large.
Yes,
huge amount. Yeah.
We need numbers. We need numbers.
Yeah, I need numbers. Yeah, I need numbers because if he said large amount of these gases, firstly we have to make they have to make the measurements, and also we are giving this service, the measurement service. Also, they can write our sales team and they can contact with them. These guys.
There's a number now around 12,000 ppm fish market gases. It's challenging. It seems challenging, right?
Yeah, it's not a big deal, but from the chemical we can reduce this one, but those gases also occur really bad smells. What they would like to do? They would like to clean they would like to reduce the odor, or they would like to reduce the the chemicals. Sometimes when you reduce these times, the 12,000, when you reduce the 12,000 to 100, also smells occur again. Because it's not a direct relation between the odor and the legal things, numbers.
Reduce the odor, he says.
Yeah, reduce the odors. Maybe they can use wet scrubbers. Make a chemical. Also, it will be make a chemical reaction. But the temperature. What about the temperature? Because as I know from my last experience, the fish markets has a high temperature.
Yes.
If it's around 80, 70 Celsius degree, it can be a challenge. But otherwise, they have to use. They have to reduce the waste gas. 12,000 ppm. It can be a challenge, but the temperature and the flow rates are important.
And for extra questions, I'm offering to send the whole technical details, about their system to our sales address, sales@eager.de, and we can evaluate it with our R&D team and technical team, and we'd like to be your solution partners for fish market or any other industries. Now there's another question: how to deal with sudden fluctuations in flow rates towards the scrubbers? Are there scrubbers or means to deal with intermittent operation other than cartridge scrubbers?
The dry and the wet scrubber, the absorber and the scrubber, the differences is the flow rate and the concentration. The absorbers can be used efficiently around 8,000 cubic meter per hour, and most of the chemicals around 100 ppm. If your gas is on this class, you can use the absorbers. But if the flow rate increases as like 10,000, 100,000, and the gas concentration around 200, 500 ppm, and you would like to reduce this one to legal numbers, you have to change your idea to dry scrubber to wet scrubber, because wet scrubbers can keep from the water and the with the chemical reaction. Both are making in the wet scrubber, but from the dry scrubber, the absorber just keeping to chemicals inside to that chemical as like a activated carbon, because the chemical the molecules go to the it's keeping at the activated carbon pores, that holes, and sometimes it's absorbing, it's a chemical, or absorbing, it's a physical reaction. So it depends to what's the flow rate, what's the concentration, and what's the customer demand from the outlet of the scrubber or absorber.
Okay, thank you. And another last one questions, I suppose. Is Noah scrubber type best in industry for H2S scrubbing, or biological scrubber with bacteria?
H2S.
Maybe there is a typo there, Noah scrubber.
Yeah, no, it can be used, the H2S, but the concentration is really important. Yani, as I explained, the flow rate and the concentration.
Yes.
Those are the main parameter while changing the type of scrubber. The third one is temperature. If you define the flow rate, if you define the type of gas or gas composition, if just as like the biogas production company, if they would like to use absorber, the dry scrubber, the methane and the other kind of things can make the blocking to filter, so they cannot use these kind of things. Before giving the decision, they have to answer 3 questions: what is the flow rate, what is the gas concentration, and what is the temperature. Different answers change to type of scrubber. The H2S also, they can use a bioscrubber or they can use the wet scrubber. If they use the wet scrubber, it turns the H2S hydrogen sulfides turns to acids, as like on the wet while washing, H2SO4, sulfuric acid. But also you can neutralize this one for the chemical reaction. It turns to salt, and they can drenate to anywhere.
Okay, thank you for the information and the presentation. Yes, I suppose we can finish our webinar here. We thank to all attendees, and as I mentioned, you can reach us out with our sales mail address and websites which I shared, and you already received mails by me, and you can write as a reply to that mail. And last one question, and we can finish. Last one, maybe 2 minutes. What minimum pressure is inlet of scrubber?
I don't know. Because I don't
Too
know.
general question, right?
Yeah, it's not a general question because, but I cannot say anything from the inlet pressure to the scrubber. Scrubbers are working as an atmospheric condition generally, but
Yeah.
for the if it's a pressurized, if it's working after the reactor, it's a high pressure release from the reactor. Also, I cannot say anything. It's not. I cannot say it's a minimum. The minimum means the atmospheric side, atmospheric condition. Yeah, it's
Okay.
an atmospheric condition.
Thank you, Hasan. Let's finish here. Thanks to all attendees again, and hope to see you soon for another webinar, or hope to communicate with you via email, and we will be waiting for your any kind of questions regarding scrubbers or other products of Agar. And thank you again. Have a nice day to all. Goodbye.
Okay. Thank you. Bye bye.
Bye.